We're here today at Manchester University, which is CAS's regional centre for the North West. We're talking to John Stout, who is a long-standing member of CAS, was on CAS's board for quite a while, works at King George V College in Southport, and has been a long and enthusiastic advocate of BYOB, or SNAP as it's now called, which is a graphical, block-based language that provides a step on from Scratch. So John, thank you ever so much for your time this afternoon. Superficially, Snap looks an awful lot like Scratch. Is it very similar to Scratch? What can it do that Scratch doesn't?
The key difference is, the first thing, as you say, is it looks the same. If you put a student who knows Scratch in front of it, they will not have any problems. They can use it. Key differences are that it made a pretty early decision that it wanted to be able not just to define simple procedures that did adding up a list of numbers or something like that, but they wanted to be able to define procedures which, through the magic of something called functional programming, could actually design new languages, new control structures, new ways of writing programs.
Okay, so we have here a block-based visual programming language.
Yep.
That we can use to create a whole other programming language.
That's right.
That's amazing, it really is.
Yeah, it's also nice, you don't have to go the whole way to defining a new programming language. You can just take, particularly, say there's one thing that you find your students having problems with. One of the examples I use is not. We've got this not thing which says, take something that's either true or false and reverse it. And sometimes we want to have not in an if condition. So we want to say if not x is 5. But it seems to be quite difficult for students to get to grips with. So what we can do is, using Snap, we can define an unless.
So a new control structure added into the language.
Just says unless x is equal to 5, do this.
Yeah.
We've removed that problem. Another example I use is probability. We teach probability, and when we're doing simulations we say, well, what you do is you pick a random number between 1 and 6, and then you say if it's equal to 4, that, for example, then we do this, and that means we've got a 1 in 6 chance. Well, with Snap, what we can do is we can just define a new block which says with a in chance, do this.
My gosh.
So instead of getting all this nasty detail, we can smooth the way that students can learn.
Which captures this idea of abstraction.
Abstraction.
That somebody else,
yes.
In this case the teacher,
yep.
has worried about how to implement this. Here is
That's
just
right.
something which you can use in your program. Yep. And so Snap works in any browser, you could use it on any device. Will it work on an iPad or another sort of tablet?
You can use it on practically everything. They do recommend Chrome. I use it on my phone in Chrome, which is Android. I use it on my tablet, which again is in Chrome. Chrome seems to have the best support, okay. I must admit. One or two things aren't quite as easy to do, but that's simply because they're tablets. You don't have quite the same thing. But in general, it's written in JavaScript, so it should run on any browser that has pretty good JavaScript support.
So can you give us some examples of things that you can do in Snap that you couldn't do in Scratch, or would be very difficult to do in Scratch?
This is one of the things where I think you can immediately show them that everything they've learnt in Scratch will work. For example, there's a rather nice setting that you can do. For example, this is a drawing a tree using a recursive procedure. What we can do, one of the settings allows us to have what are called input sliders. And also, if we click on execute on slider change, now at the moment I've got a straightforward procedure. If I press the space key, it will run. But now, if I look at these parameters, if I click on one of the
that's
parameters,
nice, yes.
I've got a slider. If I do this, as soon as I change the parameter, the script re-executes. So if I pick one of these, that one.
Wow.
So now I'm being a bit too quick for it.
That's surprisingly fast, though, for
It
that
is.
level of recursion.
It is. And I can change that, and I can see what they do. I mean, just imagine trying to work out what values of parameters you want to get that sort of a tree, whereas just by sliding, I've done that.
That's very nice.
It's
yes,
a really
yes, yeah.
neat.
And this is all happening inside JavaScript, inside the browser.
Inside
There's-
JavaScript,
yeah.
inside the browser.
Okay, so I can see how Snap provides a step on from Scratch, from that sort of building block language. What about, though, the transition onto a text-based programming language, which we're expecting to cover by the end of Key Stage 3, and certainly the exam boards are expecting in terms of GCSE specification?
Well, there are a couple of ways we can approach it. One is that, again, another setting is that we have keyboard editing.
My God.
I just shift-click somewhere on the stage and I've got a cursor. And now let's suppose I want a standard sort of sprite going in a circle.
All right.
The first thing I want to do is clear. So I do CL, and this has now brought all the blocks up which begin CL. I'll then say go to middle of the screen. I want pen down. I should really have a pen up. Let's put a pen up right at the start there.
And you're just using the arrow keys to move around
Arrow keys to go
your
up.
code, just
If
as
I
one would
decide
in a
I
text
want to
editor.
change there, I can just go there, press enter and put in 100, tab will take me to the next one, 150. There we go. Pen down, and then I go forever. Inside the block, I can then say move 10, turn 15, let's go that way. And now to execute it, it's Control Shift Enter, and there's my thing.
Okay, so we have a text-based programming language,
Text-based
which is just
programming language.
represented
Yeah.
as building blocks on screen. Yes.
It's a lot faster. I can just escape that, shut that down. It's a lot faster because you always have with the block, because of these categories up at the top left of the screen, you've got to change the category to drag the right thing
Yeah.
out.
Yeah.
So that's the first thing to do. There's an experimental feature called codification, and there's an example project on this. And basically what you do is you define a mapping between any of the standard blocks and text. So, for example, here I've got a project which, if I run it, just does FizzBuzz. So there's my FizzBuzz. And now what I can do is I can set my script to all of this code. There's a little feature, there's this little grey ring around this, which means that it's not actually going to run. I'm going to set this script to be all of that code. So this is again functional. I've set that to be code. If I look at script now, you can see on the thing, that's one of the nice things I like about this is that I can make the stage bigger. So we've got that. So the script is that. I'll now hide that. And then what I'll do is I'll say, shall we have it in JavaScript? See what FizzBuzz would look like in JavaScript.
Right.
So we do that.
Oh my gosh!
And what's happened is that the code has, because of the mapping, because we've taken each of the individual items of the script, has a mapping defined from that to text with spaces for all the parameters and arguments and so on like that. That's what it looks like in JavaScript.
Now, okay, you set that up, and you said, Miles, can we do this? Shall we have a look at it in JavaScript?
Yeah.
If I said no, I'd like to see that in Python or Haskell. Would that have been an issue?
Not too much, or we have a different set of mappings.
Right.
So, for example, for historical reasons, there's a map to Smalltalk, because that's what the original Scratch was implemented in. Yeah. I can just run that, and there's my Smalltalk code. I've got a map to Python, There's my Python code. I can take any of these boxes, and if I can do a right click, I can export it. So I can take that code, export it. It's now become a code.txt text file. I can open it, and there's my code, which I can just export and something like that. So we've got, we've also got a mapping to C, so I can change it to C
if you really
want to. It may not be the most efficient mapping, but it's a good way to get started.
Yes.
And it shows that you know, I have this problem with people who say, it's not real programming. Why isn't it real programming? You're manipulating data. You're doing control structures, you're doing procedures. Well, with Snap you're doing procedures and functions. It's as real as any other programming. Are we going to say that Visual Studio, because I can do if tab tab to get an if structure, isn't real programming?
It's fair to say it's unlikely students leaving school will get jobs programming in Scratch or in Snap.
That's
but
right.
what we're about isn't really vocational training.
No.
Do you think there's any element of what we've come to label computational thinking that you can't get at through something like... No.
No. I mean, one of the nice things that is worthwhile, if you go to the Snap website, which is at Berkeley in the States, they have this course called Beauty and Joy of Computing.
Yes.
And what they do is they teach quite high-level computer science concepts, not particularly to what they call computer science majors, but people who want to do a minor in computer science. And they tie it in with a book, Blown to Bits, that we've got. It's slightly oriented towards the States, well, particularly the book is, and of course, being a physical book, it's somewhat out of date. But at the same time, you can go on the site, you can take the course, and you'll learn functional programming. I really
think
don't
there's
think
an
there is anything.
version
Yes,
of this
that's
available
right.
now, isn't there,
Yeah,
for
that's
high
right.
school students?
Yes, that's right.
Snap looks like a great way into functional programming. What is functional programming, and how would you introduce that? How would you use that in Snap at that age?
Well, I think the best way to do it is if you take something that students might have a little bit, not so much trouble with, but start to think, you know, they told me computing, you know, computers were good at doing things like this. Why do I have to specify things in so much excruciating detail? Well, we know you do have to specify things, but a lot of the times we'll find, for example, you know, if we want to double a list of every number in a list, and then sometimes we might want to square every number in a list. And we find ourselves doing the same thing again and again.
Applying
we set
a particular thing to everything in a list.
In a list. And what we can do is we can say, right, well, we can, if we go to this, we have a nice little function called map. And what map does is it takes a function and a list, and it says, okay, I'll take this function, which can be whatever code you want. It doesn't have to be Scratch Snap code, it can be your code. And I'll apply it to every item of the list. And then I'll give you back another list which has had all that done. So a nice thing is, let's double. Well, one way of doubling is we'll map plus over a list. One of the nice things about this is that lists are also first class, is that in Snap I can make up a list on the fly. I don't have to start off with the list and then add things to it. So here is a list with 2, let's have another 55, whoops, been a bit too quick there, but that doesn't matter. 1, 2, 3. And now what I'm going to do is I'm going to map the plus, and there's a little bit of magic in the background which happens, which says that since I've only got a list of things, I'll fill out any blanks with 3, so it'll map 3. The plus will get mapped over 3, which means we'll get 3 plus 3. then 56 plus 50, sorry, 55 plus 55, 1, 2, 3.
So the thing goes into both
Goes into both.
gaps.
It's,
Right, okay, 'cause my notion of doubling would have been times by,
yeah.
take a thing and times it by
Okay.
2, but which should
indeed. Let's
produce
do
the
that.
same answers. I don't.
Let's make an operator. This time it's a reporter because
Okay,
it gives us back
yeah,
a value. Double seems a reasonable name for it. And we need a parameter. Let's call it double number. We'll tell it that that's going to be a number. Okay, we've got a hash sign by it to show that it's a number. We're going to report, which is like returning a value.
Yeah.
That's in the control section. I should be using the keyboard, it's quicker, but no, we don't. I don't want to report. I need to put an operator in, which is the plus operator. Number, whoops,
Plus the number. Yeah.
number. Okay, better check it just to make
All right,
sure that
yes,
it does
yes,
what
yes.
we think it does. So let's put a, come on, double 45 gives us back a value of 90.
That's
so that
very
was
sure,
right.
yes.
So now we can just say map double.
Do we need to take the 90 out?
Okay. Oh yes, we do. Because there aren't any empty blocks,
Yeah.
so it's just double 45 all the time. And now it's doubled
Okay.
it by mapping the double over the list. What it can do, one of the problems with double is that that's all it does. But for example, if I now drag my times, I get my squares. So 3 squared is 9, 55 squared is 3025, and curiously enough, 123 is 151229.
Okay.
And I can also do this if instead of one list, I give it 2. And let's put some different numbers. Let's put 2, tab 3, tab 4.
Now I'm expecting it to take the first gap from the first
Yep.
list and the second gap from the second
Yep.
list
And doing what with them?
and multiplying the two together.
Multiplying the
Yeah.
two together and giving back to the list. So if we map that, we get, it's a bit difficult to see there, it's 6, which is 3 times 2.
Yeah.
It's 165, which is 55 times 3, and it's 123 times 492.
Right.
But you
That's
could
it.
also think of it as the first list is a list of prices of
Yes.
items in stock.
Oh my gosh, we're going to be
Second
going
list.
into planner party spreadsheets unless we're
That's right.
very careful. Here.
Second list is how many of those items we got in stock,
Yeah.
and then we can do them. We might want to add up all the numbers again.
Ah,
Okay.
so
We
that
could-
produces a list.
That produces the list.
So we now want
We
to
now
just
want to
add
add
up
those
everything
up.
in a list. Is there a clever way of doing that?
There are a number of clever ways. One
Okay.
thing we can do in Snap is that we can have some more tools. There are a few libraries which are predefined for Snap.
Again, this notion of abstraction, of generalization, I suppose,
Yeah.
isn't it? We don't need to rewrite all of this code ourselves.
So one of the nice ones, there's a standard defined for Snap, which means that I can write a separate program. Because this is running in a browser, it's safe. But that does tend to mean that it can't immediately interact with its environment. So there's a standard defined, in which case you have a separate program which runs. Snap talks to that program talks to your hardware, and
Yeah.
you get results back. So for example, there's a leap motion controller.
Oh my gosh, yes.
So you
which
can use the leap motion
I
to
suspect
control
really
things.
is magic in all honesty.
Indeed.
Yes.
So let's pick variadic reporters,
Okay, thank you for that.
and there's a sum function.
Sorry, what was the technical vocabulary you just threw at us there?
That was a variadic reporter. So it's a reporter that takes a variable number of
Okay.
things. It's always a problem.
And we could
Suppose I-
easily write our own sum function.
Yeah.
This is just going across a list
Or
and
we
keeping
can
a
have a
running
look
total,
and see
isn't
how
it?
they've done it.
Oh, which is that
Okay.
sense of... let's have a
So
look at
what
the
they've
cleverness.
done is that they've said is that if the nums is what's coming in, which is a list, if it's the empty list, then the result is 0. Otherwise, it's the first item in the list plus the sum of the rest
Right,
of the items
which
in the list.
is a very functional way of defining a sum
Yep,
function,
that's
whereas
right.
a more procedural approach would be start at the beginning and keep a running total.
Keep a
This
running
is
total,
just
exactly.
saying, the problem of adding up a list is take the first thing and then add up the rest
Yes,
of the
that's
list.
right.
Yes.
Okay, so that we can use that, take our whole answer for that, run that, and I've got an error. Why is that? Oh, I'm
Right. Okay. Glad it's not just me.
That's it. Okay, so the total value of our stock, we've got 3 items at £2, 55 items at £3, 123 items at £4.
Yeah.
Total value of our stock is £663. From there. One of the things I like, and this is going to be a control block, and it's going to be unless a test do this. So I've just described what I want this to be. It's going to be a command, it's going to be a control command, so it's going to be in the control section. I can do exactly what I want with it. I'm now going to tailor this. So this test thing
Okay.
is going to be an input. So it's going to be a
Right.
parameter.
Yeah.
And I can say, just for a little bit of type, I'm going to make sure this thing is actually only ever going to be something that's true or false.
It would be helpful for a test to do
That's
this.
right.
Yes. Yeah.
So I'll pick the fact that it's a Boolean. The do is just a label. It's just in there. I could add anything in there I want. It's one of the nice things. It's nice having procedures that have spaces in them. It's so nice with the block language that I can define my procedure name to be exactly as I want, and I don't have to have my parameters at the end in brackets with commas between them. I can intersperse them. So this is going to be another input, but this is actually going to be a command. So this has now got, you can see on the screen, this is now, you can see test has a question mark after it, because it's a Boolean. And then we need to think about, well, the unless thing, it's basically going to be an if, but it's actually going to say, if that test is not true.
Right.
Now what I've got to do is, if it's not true, then what I'm going to do is I'm going to run
Whatever that
this
is. Yes, or this is. Yes.
And nicely we have in the control section up here, we have a run. There is also a launch variation of it, which launches and then continues straight away, so you can
Okay.
do multitasking. Just drag this in
Oh, nice
there.
one. Yes.
And now, in our control category, in exactly the same sort of status
Yes.
as all the rest, I've got unless. So let's just choose a simple one. Let's say unless 5 is 5. Well, unless 5 is 6. Let's start off with that. A good old say. Say 5 is not equal to 6. Okay,
Fine.
all right.
Yes.
But now if I say 5 and 5, so this is going to say, unless this is true, do that. Well, 5 equals 5, so it is true. It won't do anything.
John, thank you ever so much for your time this afternoon. Is there anything else you'd like to add?
I mean, one of the nice things is that the Scratch community is embracing things like Snap
Yeah.
and BYOB and so on. There are, if you go on the Snap website, there are particularly variants of BYOB and Snap to do with graphs, as in edge and vertices graphs. One to do with cellular automata or simulations, so ants picking up things. Another one which is, I personally like the idea, called Scribble. And what Scribble does is it gives you lots of drawing tools, and you can do generative art. using that. Again, all based on BYOB, and BYOB was based on the original Scratch code. GP sounds as the aim behind GP is that it's going to be general purpose, and people will be able to use it not just for demonstrating things, they'll use it for real life problems.
So whereas I said flippantly nobody gets a job programming in Scratch or Snap, you think people may
get
get
a job
jobs
in programming in GP?
Wow.
I certainly hope so.
It's going to be very interesting to see.
It's going to be fantastic.
John, thank you very, very much. Thank you.
Pleasure.
Don't miss out on Computing at School's great content here on YouTube. Subscribe to our CAS TV channel.